Hi guys, this is Achut. Thanks for watching the first video. Let's get back to the second video, which is the second lead code question, which we'll be solving today. So let's get into the work. This is the actual question we are given. Suppose there is a partition array of maximum sum. The question states that we are given an array and we need to break the array with the maximum length of k, so that after we are doing the partition, we need to maximize the sum of an array. Let's see an example. Suppose we are given this array and the k is 3. So we can break the array into subarrays with a maximum length of 3. Suppose let's take this one. Suppose let's take 15. So if we make this subarray and convert every element to 15, then it becomes a maximum. But we are given one more constraint, that is k equal to 3. That means we can break the array into subarrays with a maximum length of 3. So it should start from 0 and then 2, 0, 1, 2. So, and then we'll convert those elements into maximum element of that array. That will be 15. And then for 9, it will be 9. And then for 2, 5, 10, we'll be changing it to 10. So let's get back to the code and then what should be the intuition behind this. So we are given an array and then we are given the maximum length we can break the array into subarray, and we need to maximize the sum of the array after doing the partition. So why should we solve this? There should be reason behind whenever we are doing something, right? Let's take a real world example. Suppose let's say I want to execute, I was given some shares of company, and I want to sell so that my maximum selling price will be more using wait period, which is k, and we need to sell one share in such a way that after waiting for k particular time, we can sell with the maximum particular price, and then we can sell it to all the people. Yeah, let's see the example. This is a array. Let's think like it is a stock predictor, and we are given a wait period which is k, and we need to maximize the selling price of whatever shares we are selling it to. So we'll be changing the array to 15 and then 9 and then 10 based upon this. So the topic which we'll be covering is recursion and dynamic programming. Recursion is kind of like, suppose let's say I want the sum of first 3 elements, 1, 2 and then 3. Now what I'll call is recursion of 3, which means it will take the current element and then it will call the second, and then for second it will call 2 plus recursion of 1. So recursion is kind of like we are calling the same function with different parameters. So R of 1 will be returning only 1, and then here we'll be writing base condition, so that we should stop the function. What is dynamic programming means? Like suppose if we have solved the problem like R of 2, we'll be storing in DP so that we do not need to repeat the same problem which we had solved previously. Suppose let's take a real world example. Suppose you had solved some of the problem, and if you forget whatever the solution which you got previously, then you need to solve it again to get the same solution. Instead of that, we can store that in the memory so that whenever we face the same problem in the future, we can get the solution and then use it right away. So that is the reason behind why we are using dynamic programming. And let's take an example. Let's take this array. So for each index, there will be k number of arrays, k number of different subarrays we can take for particular index. It can be 1, it can be 2, it can be 3, it can be till k, and it should not be greater than k. Why? Because we cannot go more than k, because it has mentioned in the question like it should be at most 8. So let's take an example. Let's take a small example 1, 2, 3, and we are given that k equal to 2. So we'll be calling maximum sum of array 2, and then with the length we can take length from 1 to k, right? So it should start from 1 and then it will go till 2, and we'll be changing all the elements to maximum value. So we'll be maintaining the maximum value variable and we'll be multiplying with length, which is 1, and then we'll be calling with next index, which is maximum array of 1, which is to whatever index minus the length, which is 2 minus 1 is 1. So the recursion will be maximum sum of array. This will be called here, and then we'll be solving this. And then if we hit maximum array of 0, then we'll be coming here, and then we'll be solving based on these conditions. If it is length of 1, then we'll take like this, and then it will go to maximum sum of array of minus 1. This will be the base condition. Suppose why it should be the base condition? How we need to write the base condition? The base condition we can write when whatever the parameters which are given in the function invalidates, like it is not a correct parameter. Suppose if it is minus 1, then it goes out of this array, like index goes out of this array. This is an invalid input. So we'll take that base condition, and then we'll take 0 or minus 1, so that we'll be maintaining in the function to take care of that. Let's go through the code. So here we will be having maximum array of sum, and then this will be the index, and this will be the array, and we are passing DP, which contains the dynamic programming, like it will be the cache, like if the problem is solved, it will be stored here. And then if we come to the current implementation of the function, there will be index and there will be array. This is the base condition. Like if index goes out of scope in the array, then we are going to return 0. And if this problem is already solved, then we are going to return whatever the solution we had got previously. So we'll be returning that, because we don't need to solve it again. And then for each index, there will be starting from 1 till it goes to maximum length we can go. And then we need to take care of index minus j plus 1 should be greater than or equal to 0. Because whenever we are taking subarray maximum, it should be validated. Suppose if we go out of scope and then we are going to calculate here, then it is not a valid condition. So we need to take care of that. So we are writing one more condition, index minus j plus 1 should be greater than or equal to 0. And then we are maintaining this subarray maximum so that we can use it in the answer. And suppose if the problem is already solved, then we don't need to call the function again. So we can use dp index of j. So I'm checking here as well. So if the problem is not already solved, then we are going to call the function. So this function gives us the solution. It will solve the problem and gives the whatever solution it had got. And then after that, we got the solution. So we need to use this solution in the future. So we need to store it somewhere. That will be stored in dp of index. Yeah, that's all from my video and the explanation. You can go through the solution. I'll be providing the link in the description, like the exact solution to this problem as well as the link to the problem. Yeah, you can go through that. Thanks for watching.